Hello everyone, this is Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I'm going to talk on a subject, on a topic of the subject electrical circuit and network. The subject is designed for diploma electrical engineering students, second year students, third semester. So here the lesson plan. First, let me talk about the lesson plan. So and this whole syllabus I have to cover only three topics, that is complete only three topics, that is unit 2, that is single phase AC circuit and resonance, and unit 3 principle of circuit analysis, and unit 4 this is a network theorem statement. So here today I'm going to talk on mesh analysis, node analysis, star delta and delta to star transformations. So these are the basics of this subject. So here let me introduce all of you with mesh and node and star delta conversion. So it's a very basic level of lecture. So here the first one, I'm not going to the just going to the detail on this mesh analysis. In case of mesh analysis, you all know that mesh analysis method is based on Kirchhoff's voltage law. Okay, so which is the short form of Kirchhoff's voltage law is KVL. Okay, so here a mesh is any closed path in a given circuit that does not have any element or branch inside it. Okay, so this is the property of mesh analysis. A mesh is a closed path. It should be a closed path in a given circuit that does not have any element inside it. So it does not have any element inside it. So for loop 1, B1 equals to I1 R1 plus R2 into I1 plus I2. For loop 2, B2 I2 R3 plus R2 into I1 plus I2. So how it is happening? So let me introduce with this process. So this is the loop where the current I1 is circulating in this direction, and here in the second loop the current is circulating in the opposite direction. Okay, so I1, the rotation of I1 is clockwise and the rotation of I2 is anti-clockwise. So here if you follow carefully you will find that for the first loop the V1 we are considering as our voltage, source of voltage, and then this is the current which is circulating inside it, that is I1 in clockwise direction. So here the V1 equals to I1 R1. V1 equals to I1 R1 plus, so this is the voltage, this is positive, this is negative. Now we can consider the resistance as positive negative as for the direction of the current. So here it will be I1 R1 plus I1 R1. Then this is the common terminal. So current of I1 and I2 both are circulating. So here the direction are same. So it will be plus R2 into I1 plus R2 because both the current direction is same. So for that reason this part is developing. Now here in both the cases the current is getting plus to minus, but here it is minus to plus. So that it is actually minus B1 equals to 0. The equation will be like this. So finally we can write that B1 equals to. So the equation will be actually I1 R1. This is plus I1 R1, then plus R2, I1 plus I2 minus B1, that is equals to 0. So this is the modified verb. So you can write that B1 equals to I1 R1 plus R2 I1 plus I2. Okay. So in this way we can develop the first equation of loop or mesh 1. Now going to the loop 2. In loop 2 you can find that for loop 2 we can consider plus to minus as per the direction of the current. So this is plus, this is minus. So here the first one is I2 R3. So I2 R3 plus I2 R3, no problem with this. Here R2 plus R2 into I2 plus I1 plus R2 into I2 plus I1. Then plus minus, here it is minus plus. So this will be minus V2 should be equals to 0. So you can write that V2 equals to this part. V2 equals to I2 R3 plus R2 I1 plus I2. So this is the fundamental and the basic concept to develop the loop equation, or you can say the mesh equation. So here, number one, write down the loop equation for the circuit. So a circuit is given. Calculate the current when R1, R2, R3, R4 equals to 4 ohms and V1 equals to 10 volt, V2 equals to 20 volt, and V3 equals to 10 volt. Now we are considering this one as our loop 1. So here it is loop 1, considering the current I1. This is loop 2, this is loop 3. So I1 is actually showing loop 1, I2 is actually showing loop 2, and I3 is actually showing loop 3. So for that reason, here for loop 1, if you ask to develop the equation, then this will be as per the concept which I just shared with all of you. The current is rotating in this way. So just consider plus, minus, this is plus, minus. So just look, let me show you the way. So plus R2, if we start from this position, then this is minus plus. So R2 into I1, here both the current is flowing, I1 and I3. So I1 is flowing from this direction and I3 is coming opposite direction. So I1 minus I3 will be there. Now here both two current direction is there. So plus R4, with R4 we don't have any problem. So R4 into this is I1 minus I2 because I2 is in opposite direction. I1 minus I2. So now minus V1 plus V3 because this is minus to plus, this is plus to minus. So in the last two cases we get first plus then minus, the first plus then minus, but here we are getting minus plus. So it will be minus V1 and here again plus to minus. So plus V3, that should be equals to 0. Now if we modify, we'll get this equation taking some plus minus. So it will be V1 minus V3 then minus R2. So this equation after calculating we'll get it here. Now for loop 2, so what will be the equation of loop 2? So this is loop 2 we can consider. So here again the same concept, plus minus, plus minus, plus minus. So the equation will be same concept apply here for this case also. So what is the concept? Let me talk about the concept here. So the first one is R3. So it will be I2 minus I3 because in this resistance I2 is flowing from plus to minus, but I3 is coming from the opposite direction. So it is minus I3. Then this current is getting plus to minus, so this will be plus V2. And finally, plus R4 into I2 minus I1 because I2 is plus to minus, but I1 coming from the opposite direction. So R4 into I2 minus I1. R4 into I2 minus I1, that should be equals to 0. So this is the second loop. So if we modify now with negative sign, then we'll get the same equation. Now in the third loop, you develop the equation for the third loop because it's very easy. Now I think the concept is now clear to all of you. So tell me what will be the third one. The third loop equation will be, look, this is plus minus because current is flowing from here. This will be plus minus, this is plus minus, here automatically it is minus plus. So tell me what is the equation for third loop. I R1 I3, no problem with this. Now here it is plus minus plus minus, so plus R3. So this is I3 minus I1. So I3 is plus to minus, but I1 is minus to plus, opposite direction. So it is I3 minus I1. Then again this is plus R2. Okay, so plus R2. Here it is I3 minus I1. I3 in the plus to minus, but I1 is coming from minus to plus. So R2 into I3 minus I1. Then minus V3, minus to plus, minus V3. So this is the equation that is equals to 0. Now if we modify, we'll get same equation. So in this way, we can develop the loop equation, or you can say mesh equations, both the same. So let me clear it first, then I will move for the next slide. Here, the problem of circuit, find all mesh current for the circuit shown in the figure using mesh analysis. So I already showed you that how to find this. Now look, the process is very clear. Consider the direction of current as per your choice. So you have to consider the current direction as per your choice, because for loop 1 it is 5I1 plus J2, then I1 minus I2 minus 50 angle 50 degrees. So how it is happening? Look, the direction of current is actually, it's totally depend on the user. So this is I1, this is I2, this is I3. Not necessary you have to consider the current in this direction. It is totally depend on the user. You can consider the current direction like this. No problem with it. Okay, so yes, so as per the direction here we can consider. Now we can choose the same direction. So here it will be plus 5I1, so it is plus minus, this is plus minus, this is minus plus. Okay, so plus 5I1 plus J2 I1 minus I2, J2 I1 minus I2 minus 50, because this current is coming from the opposite direction. So 5I1 plus J2 into I1 minus I2 minus 50 angle 0 degree. So this is the first loop equation. Then second loop equation, tell me, this is plus minus, the current flowing plus to minus, this is also plus minus. So no voltage source is there. So 4I2, yes, 4I2 minus J2 I2 minus I3 minus J2 I2 minus I3. This will be I3. Then plus J2, yes, this should be J. So plus to minus plus J2 I2 minus I1 equals to 0, and then minus J2 I2 minus I1, yes, minus J2 I2 minus I1, and then here it is I2 minus I1, this is I2 minus J2 I2 2, this is J2 minus, this is minus J2, yes, this is plus J2. So plus J2 means minus I3 will be there, equals to 0. So in the third loop, similar way we can develop the third loop. This is I3, 2I3 minus J2. Yes, I3 minus I2. Yes, this is I3. This is I2 minus 50 degree. Yes, this is plus minus. So minus 50 degree. So that in this way we can form the three equation, and then we are moving to the next slide. here using this matrix, just as per the matrix, put the value of the coefficient of I1, I2. Just first arrange the value, then put the coefficient of I1, I2, I1, I2, I3, I1, I2, I3. These are the coefficient of I1, I2, I3. The first equation coefficient I1, I2, I3. Then second equation coefficient I1, I2, I3. Third equation coefficient I1, I2, I3. If I1 or I2 is missing, then multiply by 2. So it is I1, I2, I3. This is the voltage, value of the voltage, 50 angle 0 degree minus 0 degree, 50 angle minus 0 degree. So the value of I1 equals to, this is the value divided by this term. So we can easily find using the matrix, we can easily find the value of this I1. This is the value of I1, 8.49 minus J4.717. I1 is this one in polar form, this is in rectangular form. So you have to solve the problem by yourself. Now in the similar way, we can find the value of I2, the matrix divided by minus J2, 4 J2, 0 J2 minus 2 J2. So this will be the value of I2. Okay, so here it is the value of I2. The next term, on the next part, the value of I3, in the similar manner we can find I3. The value of I3 will be this one, I3 600 minus J, so minus J 1200 divided by 84 minus J 24, that is 15.357 angle minus 47.45 ampere. So this will be the value. Now I'm moving to the node analysis part. So mesh analysis part is already completed. I think it is clear to all of you now that how to solve this circuit using the mesh analysis. So here I'm going to talk about part of the nodal analysis. So non-reference node. It is a node which has a definite node voltage. Now the reference node, it is a node which acts a reference point to all other nodes, all the other nodes. It is also called the datum node. Basic steps used in nodal analysis is select a node as a reference node. The number two, assign voltage V1, V2, and Vn minus 1 to the remaining nodes. Then the voltage are referenced with respect to the reference node. Now number three, apply KCL to each of the non-reference nodes. Number four, use Ohm's law to express the branch currents in terms of node voltages. And number five, after the application of Ohm's law, get the n-1 node equation in terms of node voltage resistances. So here VA, VB, VC, we consider three nodes in this circuit. So the first one is VA, second one is VB, and third one is VC.